here for the year. So if you notice, first thing, I'm kind of giving you a hint about some different methods that we are going to use. If you notice what we are going to be looking at, we are going to be solving trigonometric equations. And for what it's worth, someone in my first period class shared at the end, after he had practiced with the lesson, he said, it's not that hard, it's just that every problem's a little bit different. And that's the key, is kind of recognizing how you're going to solve. So you need to kind of think about some of your algebraic strategies that's going to help you with solving these trigonometric equations, okay? We are dealing with equations now. So there are going to be some things that we can do a little bit differently than what we were doing with our verifying identities. We can move stuff from one side of the equal sign to the other, that type of thing. In some instances, what you're going to see or what you're going to notice is that you might look at the trig equation and it might be a little bit confusing, kind of trying to visualize or think about what you have to do in order to solve. If that's the case, if you're having a hard time figuring out what you need to do, then my suggestion is that you actually rewrite the equation so that it just looks like algebra. So we're going to rewrite the equation just without the trig functions in there. So this equation would be written just as 5x is equal to 3x plus the square root of 3. So without the cosine in there, we're going to go back and put it back in here in a minute, but without the cosine in there, we get that equation. What would we do in order to solve that? Oh, and what should we do to solve for x?
Minus 3x.
Okay, so we're going to subtract the 3x. So then we have 2x is equal to the square root of 3, and then we're going to have to divide by 2, so we get x is equal to the square root of 3 over 2, only it's really not just x, right? We had this cosine here that we took out just to kind of simplify things. So what we're really looking for now is, where is the cosine of x equal to the square root of 3 over 2? If you notice, I did not write any specific directions. I do that a lot because directions can be written differently. In some instances, it may ask or say, solve over the interval from 0 degrees to 360 degrees. And then in other instances, it might say from 0 pi to 2 pi. So that's telling us a couple of things. First, it's telling us that we have to look at and consider the entire unit circle. So for many of these problems, we're going to have two answers. But it's also telling us the format to give your answer. So if it says from 0 to 360, then you know you're going to give degrees. If it's saying 0 to 2 pi, you know you want to give the radian measure, right? So I want to do a little bit of practice with both. So for these, let's do both. So the cosine of x is equal to the square root of 3 over 2. Where is that, John?
30 degrees.
Okay. Where else?
330.
I'm sorry?
330.
330. Okay. So that's in degrees. We go back and think about what the radians are. We've got pi over 6 and 11 pi over 6. So we could write these either way, right? Does that make sense? It's our first trig equation. Nice. All right, comments, questions, thoughts? Okay, let's look at this next one then. On this one, if you need to, you could rewrite using just x's in there, but I think you guys can see on this one that we're just going to add 4. And that gives us 1, and then we're dividing by that 3. So we get tan squared x is equal to 1/3. And then we've got to square root both sides in order to solve. Guys, if we take the square root of both sides in order to solve, we have to remember to consider the positive and the negative. So that is important to remember. If we take the square root of 1, we get 1. The square root of 3, we get root 3. So this rationalizes to root 3 over 3. So in this, because of the positive and the negative, we've got 4 answers, not just 2. So where is the tangent? That's y over x, root 3 over 3. CJ, where is that?
No. What's the y over x?
It's y over x, yep. You actually look for the 1 over root 3 is what you really want to look for.
Both positive?
Well, positive and negative. We need all 4 of them.
So it's, you want degrees?
Sure.
So 30 degrees.
Okay.
150.
Yep.
And then it'll be 210
Okay, keep going.
and 330.
And 330. So that's in degrees. We can put the radians there also if we needed to. We'll just leave it with the degrees for now. There you go. Excellent. So you have to remember, if you are square rooting both sides in order to solve, you have to consider the positive and the negative. Okay? In some instances, you are going to have to factor. And sometimes it's just factoring a GCF. Sometimes it's a little bit more involved than that. So let's look at, we're going to switch letter B, and you'll see why in just a second. But if you notice, this is saying solve over the interval from 0 to 2 pi. So we're going to want to give our answers in radians. Okay. Knowing this hint of we might have to factor, I'm hoping that you recognize that our first step here is going to be that we need to move this that's on the right-hand side over to the left-hand side and get it set equal to 0. Remember, we need 0 in order to start our factoring business. What's our common factor there that we can factor out? Alex?
Sine x.
Sine x, good. So if we factor out a sine x, then we are left with 2 cosine x minus root 3 equals 0.
But isn't there still a sine?
I'm sorry?
Shouldn't it, wouldn't it be sine cosine? Because
Well, we've pulled out this sine,
I thought there was 2.
so that's what's factored out. And so what's left is this 2 cosine and then the minus root 3.
I thought there was 2 sines.
We don't think, there are no squares, nothing's squared there, right? But yeah, good question. Are you okay with that though? Do you see it?
Yeah.
Okay. All right, we have 2 terms here now that are getting multiplied together that are giving us 0. So that means we have to set each of these factors equal to 0. So we're gonna say sine of x equals 0, and this 2 cosine of x minus root 3 is equal to 0. So we still have a little bit of solving here on the right. I wanna add root 3 and divide by 2, so I get cosine of x is root 3 over 2. All right, Sam, help me out. Sine of x is equal to 0, where is that? And we're giving radian measures.
2 pi, 4 pi.
Okay, so 0 pi and then pi. Technically, if you look at how this is written, notice this is a bracket and this is a parentheses. So it's saying we want to consider full unit circle, but the bracket's saying we want to give 0 pi and not say 2 pi, right? Does that make sense? Because of the bracket? Okay. And then where is the cosine of x equal to the square root of 3 over 2?
Still me.
Still you.
Pi 6 and 11. Pi 6.
Pi over 6 and 11 pi over 6. There you go. We have a whole bunch of answers with pi over 6's in them, so that's why I'm changing letter B so that we don't have more of those, because I don't want you thinking that all of your answers have to have a pi over 6 in them, because they don't.
Usually the sine and cosine, right?
I'm sorry. So yeah, for this last one, let's switch those sines to cosines. Okay. Okay, This is one where I think it's definitely easier to look at just the algebraic form in order to be able to factor this. Because this is not just reverse FOIL, we've got a 2 out in front. But this one's not too bad to factor, right? Think about the fact we need to multiply to get 2 up front, so 2x and x. And we need numbers that multiply to give us 1 in back, so that's obviously 1 and 1. So the key here is looking at what we get when we multiply those terms together and combine those. So this gives us a 1x and a 2x. Guys, remember whatever this sign is, the bigger of these two values needs that sign. So that means this needs the positive, this needs the negative. So that equates to this being negative, that being positive. Take a look at that, make sure you kind of follow how I figured those signs. Are we okay with those signs? Does that make sense to get the positive 1x? Because I'm going to erase that now. Wow. There we go. Okay, we got to put the cosine back in there also. So I'm gonna write this step first. And then I'm going to solve for x and put that cosine back in there in the same step. So I'm adding 1 and dividing by 2. And so I want the cosine of x is equal to 1/2. And the cosine, oops. The cosine of x is -1. All right. So, Elena, where's the cosine of x equal to 1/2?
5/3 and 5/3.
Yeah, sounds good. And then cosine of x is -1. There's just one answer for this, guys.
Pi.
X equals pi. There you go. Awesome. So as hopefully you do kind of notice, it's not too bad. You have to think about how you're solving equations. There's one other example that I want to work out with you completely. And then there's kind of some hints on some of this homework that I want to be able to give you as well. Okay? So hints first. On this first one, I'm noticing sines on one side and cosines on the other. You guys just thought you were done with your Pythagorean identities. For this one, I would suggest that you rewrite this right-hand side as 1 minus sine squared x. So you can do that substitution of rewriting that cosine squared as 1 minus sine squared x. Then you've got sine squareds for everything. It's going to be a lot easier to work with. So there's a hint for that one. Okay, we're gonna keep going though. I'm just giving you hints for now. We'll kind of go through and work through these shortly. On this one, we're solving an equation, so it is legal for us to square both sides. And my first period class, when I gave them this hint, they were like, why are we doing that? Well, because we have Pythagorean identities that have something to do with sine squareds and cosine squareds, but we don't have any identities that just have sines and cosines in them. So you do have to be careful and make sure that you are foiling completely. And 1 squared is still just 1, right? You do want to make sure you foil that completely or you're going to be a little bit messed up. That one's pretty straightforward. Guys, this one is already factored. There is no need for you to foil. You set this, break that up and set that equal to 0. Break this up and set that equal to 0. Okay? So those are just some hints on that page. I will show you the hints on this next page too. And we'll get to this last one. The last one is the one we're going to do all together. There's some GCF stuff going on. This one is kind of a logical thinking type problem. Think about what this is saying. This is saying that the tangent, which we know is y over x, has to be equal to the cotangent, which is x over y. So I'm going to give you that hint. And then on these last two, you are going to do a substitution again with your 1 minus sine squared or your 1 minus cosine squared. So you're going to rewrite either your cosine squared or your sine squared for both of these. Okay, all right, and then let's take a look at this one. I rewrote using just algebra so that you could see that. And what I need you to notice is that that does not factor. So if we have a quadratic equation that does not factor, how do we solve? Quadratic formula. So this would be a bonus type question. So I want you to be kind of familiar about how complex they can get. This would be like a bonus question. So don't get too stressed about this, but I do want you to be familiar with the process. So opposite of b plus or minus b squared minus 4ac all over 2a. So I did get rid of the cosine, but we'll bring that back here in just a minute. I want to clean this up first. So this part right here is plus 16. So that we have 16 plus 16, so we get 32. Because that's minus a negative, so it becomes plus, right? Okay. So we get negative 4 plus or minus, that's 16 times 2, so that's 4 root 2 all over 8. And as you know, we have to consider Mickey Mouse ears, and we definitely have that here. So I'm going to kind of do this now in one step. I'm going to break it up and clean it up and add the cosine. So we have cosine of x is equal to, if we divide out that common factor of 4, we're going to have negative 1 plus 1 times the square root of 2 all over 2. And then the cosine of x is negative 1 minus the square root of 2 all over 2. So we normally write it as a plus or minus, but in this type of problem, you have to think of them separately because it does give you two different numbers. And this is one that you would have to just go straight to your graphing calculator at that point and plug that value in and see what you get at that point. So you would get x is equal to something from that answer, and x is equal to something from that answer. Okay, so pretty complex that they can get, but I promise the ones you are dealing with, not quite so bad. I kind of gave you some hints, and I'm giving you time in class so that, you know, you can work with somebody and you can ask questions of me. So I'm just kind of going to float around to help you with these. So move desks, work with each other, and I'll be peeking over shoulders and helping out too, okay?